Welcome to this tutorial where you are going to learn about industrial motor control and protection. The learning outcomes of this tutorial are that by the end of this session, the trainee should be able to explain different methods of starting three-phase induction motors, state electrical components used in motor control panels for protection purposes, and explain the different methods of speed control of induction motors. To start with, let us look at the method of starting three-phase induction motors. Generally, these three-phase induction motors, during starting, they draw a lot of current, 6 to 8 times the full load current, and therefore you need to come up with mechanisms of how you can limit that current. We have two categories: across the line starting and reduced voltage starters. Across the line starting is what we call direct online or forward reverse. Forward reverse is just a special kind of direct online. The only difference is that in forward reverse, we have two contactors, the forward contactor and the reverse contactor. Hence, the motor can either go in forward direction or reverse direction. Then we have reduced voltage starters. The main reason why we apply reduced voltage starters is to limit the inrush current during motor starting. The reduced voltage starters are generally employed in motors above 5 horsepower, but in across the line starting, these are motors with less than 5 horsepower and therefore they don't have much effect during starting. So in this category of reduced voltage starters, we have star delta and auto transformer starters. Then we also have other means of starting these machines like variable frequency drives and soft starters, part winding starting, and by use of primary resistance. These primary resistance are majorly employed where the machine requires to drive a load which is of high starting torque, and therefore like the cranes which are used in sugar factory. To start with, let us look at the star delta power circuit. When you look at this circuit, you realize that there are some components. We have MCCB, that's molded K circuit breaker for short circuit protection. We have a thermal overload relay that is used to protect the motor from overloading conditions. Then we have three contactors: the main contactor, the delta contactor, and the star contactor. The star contactor and the main contactor will be energized during starting, and after a period of time set by the timer, the star contactor will be de-energized and the delta contactor will be energized. Hence, the motor will start on star and run on delta. That's why we say it's a star delta starter. When you look at the control circuit, you have your thermal overload relay, the normally closed contact, that is terminal 9596, connected in series with the normally closed push button and normally open and the normally open start button. Now, the main point you need to take note of here is that there should be electrical interlock between the delta contactor and the star contactor. How is this one achieved? This one is achieved by use of the timer and the auxiliary contact of the respective contactors. As you can see, normally close contact of the timer is connected in series with the normally close contact of the delta and in series with the star and in series with the coil of the star contactor. That means that whenever the delta contactor is energized, whenever the delta contactor is energized, whenever the delta contactor is energized, there will be no current that will be flowing in the star contactor. That means that the normally closed contact of the delta contactor will be open. Hence, we will not have any current flowing through the star coil of the contactor. That means that the star contactor will be de-energized. The same principle will apply on the delta contactor while the star contactor is energized. Then we have the direct online. In direct online, we only have one contactor. Since it is DOL, we don't need a timer. Then we have circuit breaker for protection purposes, and we also have thermal overload relay F1 for overload protection. It has a control circuit which is almost similar to the star delta, but in this case we don't have interlocks because we only have one contactor. Then we have a motor protection scheme. Induction motors can be protected from many conditions, that is overloading and poor quality problems. Overloading conditions are as a result when the motor is required to produce too much, turning action against its rated capacity. Therefore, this one is being done by a component called overload relay, which is set according to full load current of the machine. Then we have power quality problems, over voltage, under voltage, phase imbalance, single phasing, and wrong phase sequence. All these power quality problems can be checked by use of a phase failure relay. Speed control. How do we control the speed? Speed of a synchronous machine is given by 120 F over P, where P is the poles and F is the supply frequency. Assuming that P is fixed, you can change the supply frequency. One of the ways of changing the supply frequency is by use of solid state electronic devices like variable frequency drives, which has the capability of changing the supply frequency. Thank you.